Yeah, good evening, everyone. This project is about the air quality index prediction, and here in this particular machine learning project, I've also used deep learning over here. The algorithm you can see that it's LSTM and GRU, and after that, I've also used transformer. So three algorithms I have used where LSTM and GRU is actually performing extremely well compared to transformer, and transformer is also performing well, but not as much as LSTM and GRU. LSTM and GRU are doing good. Now you see here we have import request pandas and all these libraries I have imported. The first cell is for the libraries, and here I've uploaded the data set. Okay, and this is the only thing that you have to upload. Rest this H5 extensions, PKL extensions, whatever you are seeing over here, all these are the models that we have saved after writing the codes. So I have just read the data set, and you can see in this particular data set everything is the feature, okay, except this to PM 2.5. This is basically the target column. Okay, this is the target column, and the rest everything is the feature. So after the analysis, after the columns, seeing the description, statistical analysis, you can see there is no such null values. Okay, there is no duplicated values. Okay, and there are total 1800 18,776 rows and 8 columns. Okay, and I've given some visualizations over here. After giving the visualizations, you have split the features and the target. So this is basically the feature, and the target is actually PM 2.5, right? And I just separated the feature and the target. After that, I have scaled. I've made use of min max scaler. I've scaled the data. After scaling, I have just gone for the correlation heat map. Okay, the correlation mapping, and after that, I've just plotted some more graphs. Okay, that is basically helpful in data visualization part. I've given a box plot also to detect the outliers, and def create sequences. This create sequence function is basically we are taking last 24-hour data in order to predict next 3 hours data. Okay, so this function is particularly for that. So you can see over here I've written look back 24 and forecasting for next 3 hours. I've called the sequence create sequence function. I've passed the data sets. Okay, after that I've divided the data set into training and the testing, where 80% goes to testing, training, and 20% goes to testing. I've created LSTM model. After training the LSTM model, I have saved the model. Then I've created the GRU model. After training the GRU model, I've saved the model. Then I've saved the PKL also, mean the mean max scaler. Then I've tested the LSTM and the GRU. After testing the LSTM and the GRU, I've tried to print the errors, and you can see that I've given on visualization, and LSTM and GRU are performing absolutely equal. Okay, so LSTM mean absolute error is 0.03, and root mean squared error is 0.05. Okay, root mean squared error is 0.05, and similarly for GRU also. And I've given the prediction for the next hours, that is the next hour prediction I've given. I've also given some more graph for the t plus 1 hour for the next 1 hour. Then I've given the graph for next 2 hours. Okay, 2 hours. Then I've given for next t plus 3 hours. Okay, next t plus 3 hours I've given the graph. And after that, you can see that I made use of I've compared the complete actual value and the predicted value in a data frame. If you want to save the data as well, you can just uncomment this line. Okay, and I made use of transformers also. I made use of transformer. We can make use of transformers also. You can make use of transformers. I've made use of transformer, and after making use of transformer, you can see that the transformer is actually giving error slight higher compared to LSTM and GRU. So LSTM and GRU are performing better compared to transformer on this particular data set. Okay, and with the help of transformer also, I've given the next hour prediction, as well I've given the prediction for the next 3 hours also. Okay, so here we have successfully completed the project, but I have also built one user interface. You can see the user interface over here. Okay, so in order to start the user interface, simply you have to go to this particular folder, and you have to write a flask run. Okay, once you write flask run, it will take some time to start the user interface, because the UI is basically built on a Flask framework. Okay, it's totally built on Flask framework. So we have basically made use of the Flask framework. So you can see it's giving on URL. So you have to copy this URL. After copying this URL, you have to go to this particular, and you have to paste it over here. Now whatever you can give some carbon monoxide values. Okay, you can give some nitrogen oxide values, you can give some nitrogen dioxide values, you can give some ozone values. Okay, you can give some sulfur dioxide values, you can give PM 2.5 values, you can give ammonia values. Okay, and you can get the prediction. Okay, so after giving the prediction, giving the values, this is basically user interface. Okay, from where you can give your input. After giving the values, you can see that you will get some predictions, right? You will get some predictions, and it will also give you some suggested actions. right? It will give you some suggested actions. Okay, it will give you some suggested actions. So suggestions I have made of my own. Okay, this is a dummy data where you can see that I have one column called a PM 2.5 range, and if any values falls between this particular range, you can also create your own range, you can create your own suggestions. So it is going to give you the suggestions, which is basically called the solutions. Okay, something like that. So that's it, we have successfully completed our particular project, right? So it's taking some time to load. Let me do one thing. If it takes some time to load, just close the server, just close the server. Okay, just close the server, start it once again, close the server, start it once again. And after starting the server, you can provide the values, you can provide the values. So till the server gets started, let the server get started. Okay, let the server get started, and you can see, yes, it, of course, it has started. Now get some carbon monoxide values. Okay, give some nitrogen oxide values, give some nitrogen dioxide values, give some ozone values. Okay, give some sulfur oxide values, some P10 point values, and some ammonia values. So this value is typically very high, don't give so much high values. Okay, so and let's you click on this prediction. Okay, so you can see it is giving you the predicted result, and it's giving you a suggestion also. Okay, thank you everybody, the project is completed. Thank you.